Hi, welcome to the Olympiad geometry. Let's continue our study. Before we start, if you think this video is helpful, please click the like button, comment, share, and subscribe to the channel. We're going to keep talking about the correlation of the centers of triangles. So let's see the problem. Let GH be the centroid and orthocenter of I-cubed triangle ABC. If tangent A, tangent B, tangent C form an arithmetic sequence, then GH is in parallel to AC. Here we need to use conclusions that we got before. We actually derive how to get it before, but here I won't derive it again. I'll just write it down. So we know that tangent A, tangent B, tangent C form an arithmetic sequence. That means tangent A plus tangent C equals to twice of tangent B, right? And we already know that tangent A times tangent B times tangent for a triangle, okay? For a triangle, tangent A times tangent B times tangent C equals to tangent A plus tangent B plus tangent C. And we know that tangent A plus tangent C, that's twice of tangent B, which means it equals to 3 times of tangent B, which means tangent A times tangent C equals to 3, right? And think about these 3. We should be very sensitive of these numbers. It's 3. And we want to prove that GH is in parallel with AC. G is a centroid. And for the centroid, it has a property that relates to the 3. Right? Let's just draw a figure here. I will need to use a circumcircle, so I just draw the circumcircle first here. So this is an I-cubed triangle. And remember that for the centroid, we know the distance from the centroid to the vertex, to the distance, the ratio of the distance from centroid to the vertex, to the distance from centroid to the opposite along the median. That distance is 2 to 1, right? Which means that this to this is 1, 2, 3. So let's call it M here, call it N here. Call this point as P here. Then this is G. That's the centroid. We know that GM, or actually we want to prove that GH in parallel with AC. So let me draw the this is H, right? We want to prove that GH, see, G is here. We want to prove that GH is in parallel with AC if this is valid. So we just need to prove that GN to BN equals to HE to BE equals to 1, 2, 3, right? Then we just need to find, we want to prove this equals to 1, 2, 3, and we know that tangent A times tangent C equals to 3, which means cotangent A times cotangent C equals to 1, 2, 3, which means we just need to prove HE to BE equals to cotangent A times cotangent C, right? Which is cosine A cosine C to sine A sine C, right? So let's just times 2r on the numerator and denominator. So we got 2r cosine A cosine C to 2r sine A sine C. We want to prove it equals to HE to BE, right? That's what we want. Let's check on BE. What's the size of BE? BE. BE equals to BC times BC times sine C, right? This is B, this is angle C, BC times sine C, that is B. B is perpendicular to AC, right? So B equals to BC times sine C. And what is BC? BC is 2R sine A, which means BE is 2R sine A times sine C. BE equals to this one. So we just need to prove that HE equals to 2R times cosine A cosine C, right? HE. So here we need to use a thing that we discuss a lot, right? Just connect, for example, C and O here. This is not concurrent, right? O here. So let's call this point as, for example, X, right? Then we connect AX. So what we get here? We know that AHBX. So I want them to be, these are not concurrent. I just repeat it again here. So AX, we know that AHBX is a parallelogram, right? That means AX equals to actually BX. Yeah. BX equals to AH equals to 2R times cosine A, right? Because this is 90 degree, this is angle A, this is angle A. So BX equals to 2R times cosine A, which equals to AH. And AH times, look at, now, yeah, let me redraw the figure here. Now look at this angle, the angle AHE, right? The angle AHE equals to angle C, right? Because angle AHE plus angle DAE equals to 90 degree. Angle C plus angle DAE equals to 90 degree. So this angle equals to C. That means AH times cosine C equals to HE, which means HE equals to 2R cosine A, which is AH, times cosine C, that is HE. Then we know, based on this one and based on BE, we know that it is true cotanent A times cotanent C equals to HE to BE. Sorry, BE to A, let me see. Yeah. HE to BE, right? This is always true. But in this case, in the problem set, we know it also equals to 1, 2, 3, which equals to GN to BN, right? That means GH is in parallel to AC. Okay? So for this problem, we shortly reviewed what we learned before. We actually need to use this equation, which we derived before, and we also need to use the concept that I mentioned, I don't know, 1,000 times, that when we see the author center, we always should keep in mind that we can use this circumcenter to find a lot of parallelograms and translate or transfer each edge to the chord, right? The edge of a triangle to the chord. Okay, that's it. I hope you like this video. See you in next one. Thank you.